Welcome on online wireless mobile communication lectures. Today our topic is mobile radio propagation. Wireless mobile communication, and today we having the topic is mobile radio propagation. We already know that there are the two ends which are connected by a free space, or you can say in open space. The one end which transmit the signal is transmitter, other end who's receiving the signal is receiver. In this topic, the mobile radio propagation is effect on the performance of the receiver. Why? Because look at this. This is one is the free space. This is called the channel. So the wireless channel, or we can say in other words, the wire channel is susceptible to a variety of transmission impediments such as the path loss, interference, blockage, obstacle, abstract, degrade, attenuations, reflections, diffractions, and so on. So many things which effect on the which restrict the range of data rates and the reliability of the wireless transmission. Consider this figure. It is this block is telephone network. The first block, which is called telephone network, and it is connected, its MSV. This is connected to another NSV. For in this NSV there are connection between the base station. The base station is nothing but it is the tower. Tower is called the base station. This tower is radiate the electromagnetic waves in a free space, and in this free space the waves are propagates, means they are moves from the originate source to the destination ends. It means they are allowed to propagate these radio waves in a free space. And here is the MS. MS means mobile station. Every mobile station get the signal from the tower, from the base station, and every base station is connected to the mobile switching center, and this mobile switching center is now connected with the telephone network. A same thing is happened here. Again, this is connected with the tower, this also connected with the tower, and they allow to guide the wave, the electromagnetic waves in a free space to exchange the information between the users. This constitutes the, or we can say, this makes the basic mobile communication structure. So it is the basic mobile communication structure. Now look at this free space. This is the free space. This one is the free space. This is the channel. These are the channels. And these channels allow to EM waves to propagate. So the main problem is occur in the channels, and our topic is mobile radio propagation. Before we move from this topic, so let us see the propagation of the radio waves, how they can propagate. Consider this is our earth, like this way, spherical, and there is a one layer just above the around 20 to 16 kilometer above from the surface of the earth. And if again we have the distance from earth surface towards the up direction, and it is around the 40 to around 500 kilometer, and roughly it is taking near about 50 kilometer to 400 kilometer approximate. So this is another layer from above the earth surface. This upper layer is known as ionospheric layer, and just beyond this, the second layer is known as the tropospheric layer. So the tropospheric layer or ionospheric layer allow to propagation, to move the waves in this layered region. It's also allow the propagates the waves in tropospheric layer regions. Consider here is one person, and at this point is one person. Now at this location we have the antenna, and at this person, for line of sight we having the another antenna. This is the transmitting antenna. This one is the receiving antenna. See, this is the isotropic. This is also isotropic reflector. So it allowed the radiates the waves in all the directions. It's also allow the wave travel in this direction. It's also allow the wave travels in this direction. It's also allow the wave travels in this directions. In all the directions, possible directions. This is the transmitting antenna. It is the isospheric reflector antenna. It is transmitting the waves in this fashion. So the waves are moving from transmitter towards the receiving end like this fashion. So the first wave which is started from the transmitter towards the receiver is going this way. These waves which here is called, which is near to earth's surface, it's called the ground wave. Look at this layer. If the reflective isotropic antenna send the electromagnetic waves, EM waves, and it goes in this tropospheric layers, it is started and goes this point. I mark this, and it reflect back towards the receiver end. This is going like this way, and this coming back towards the receiver end. This is due to what? There are the certain phenomena which occur, that is known as reflection. Another phenomena which is happened here, that is called scattering. So what do you mean by reflection? When the wave is felt on one surface and it retransmit to the other surface, it's called the reflection. What is the scattering? When rays falls and is distributed unwanted directions, that is called scattering. Due to reflections and scattering, the waves are abstracting the waves. These are diverting the waves. These are creating the delay to reach the waves to the end before it's take the so many obstructions, and they are coming too late at that receiver ends. Same thing is happened here. When the waves is started from this, EM waves reflected and scattering again send back the rays towards the receiver. So the trajectory and the path, the channel which are maintained, it's not behave as compared to the wired channel. In wired channel, there are the fundamentals limitations and they are not get effective. So the performance of this channel, the performance of the EM waves get affected, because in wired channel there are the predictable limit. We can predict. Two coaxial cables are twisted. The waves and the signals are going in this wire only. But in open space, the waves are coming from at what angle and what time and what shape, it cannot be predicted. It cannot not be determined. So we cannot say the mobile radio channel played the fundamentals limitation on the performance. So the male function of the wireless communication system is get degrade. So the measure of the work is done in this channel. All the requirement of to design the receiver to make the consideration to cap this limitation into the predictable limit, not going excess beyond the our expectation limit. So we have creating the certain types of receiver and transmitter. In other words, the transmission path between these two ends, this transmitter and receiver, the receiver transmitter end are vary from simple, agar we can say, line of sight. The line of sight is differ. In this, the line of sight is commonly differ when the propagation of electro waves started in the mobile radio system. So the line of sights are not improper, not in justify it because of it is just because of the many abstract, just like the trees, buildings, mountains, and one more effect of the environment, weather, like the wind blow, rains. So many factors are there. Due to this reason, the wireless channels are unpredictable because of the radio channels are extremely random and do not offer easy analysis. So the conclusion part is, due to this reason, wireless channel are unpredictable because of the radio channels are extremely random. And this is the reason they do not offer easy analysis. Unlike if we look in wired channels, if we see, the question is also arises, the wired channel, because they are stationary, and Due to stationary, they are predictable. Due to stationary, they are predictable. So the radio channels are easily to offer the analysis. If we look other counterpart, a mobile terminal moves in a free space. If the mobile channel moves in a free space, then the speed of motion impact how rapidly the signal level fades as mobile terminal moves in this space. How the signal get to connect with your mobile equipments, and what the shape they have, they connect, what which type of shape, it is the important. So 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 it is the required, therefore we required modeling the radio channel has historically been one of the most difficult part of mobile radio system design, and is typically done in statistical fashion based on measurement made specifically for an intended communication system or spectrum allocation. So the mechanism behind electromagnetic waves propagations are diverse, but can generally be attributed to reflection, diffraction, and scattering. The three basic phenomena. One is reflection, diffraction, and scattering. The most cellular radio system operate, we know that, in the urban area where there is no direct line of sight. So the pan between the transmitter and receiver, and where the presence of high rise building, so the signals are not easily to reach their destination. So we have required to learn the wireless propagation model, the